Hello, these are a series of 5 videos to help you to answer maths questions in biology. You are tested on just over 30 maths skills in science, and we want to make sure you have every opportunity to do the best you can. So I'm going to talk you through some typical questions that you may come across. So this one then, first of all, a student measures his reaction time using a computer test. He repeats the same test 6 times. His results are shown in the table below. Calculate his mean reaction time to 2 decimal places. Now, I always use a highlighter to highlight to me what are the important parts of the question. And also, this is absolutely crucial. You'll see little things like this appear at the end of a question, and lots of students miss it out. You must write the answer to 2 decimal places, otherwise you will lose the mark. Now, this is a straightforward calculation. It's a mean calculation. So you add up all 6 results, divided by 6, and you get the answer of 0.241. But because it's to 2 decimal places, the answer is 0.24. Okay, question 2 then. There are 8.5 times 10 to the power of 4 white blood cells in a blood sample. 2/5 of these are lymphocytes. How many of the white blood cells are lymphocytes? Well, the first thing you've got to do is you've got to work out what 1/5 of that is, okay? Now, you could actually expand the whole number by working out what 10 to the power of 4 is and then multiplying that by 8.5 and then dividing it by 4. Or if you've got a scientific calculator, you can do 8.5 times 10 to the power of 4 divided by 5 equals 17,000. That's 1/5. I want 2/5. So that times 2 is 34,000. But I'm going to give my answer in standard form as well. It's 3.4 times 10 to the power of 4. Okay, question 3. Now this is one of those, I call these a tricky question, because what they're trying to do is give you lots of information, but you don't actually need all of it, but you've got to search for the clues. A combination of 2 alleles, capital N, lower n, controls wing shape in fruit flies. The combination capital N or capital N lower n produces normal wings. The combination lower n produces vestigial little wings. The genetic diagram below shows the possible outcomes when 2 capital N little n parent flies reproduce. Now you might look at all of that and think, gosh, that's a lot to take in. And if this sort of question was asking you to predict what the wings would be like, we could do that. But this is a maths question. And this is the clue here. All of the outcomes are equally likely. So every single outcome is going to be the same. So if 2 parents had 164 offspring, how many offspring would be expected to have? Well, I've got 4 possible offspring combinations, and it says they're all likely to be equal. So all I do is take my total amount of 124 and divide it by 4, and the answer is actually 31. Now, question 4, this is a graph question, and these do come up a lot, and they are worth a lot of marks and worth getting right. Omar is investigating the effect of pH on the activity of the enzyme amylase. Some of his results are shown in the table below. Now, always remember, the independent variable is the one at the top, and the dependent, the one that was measured, is the one at the bottom. Plot the results in the table on the graph below. And then, this again is a bit that a lot of students miss out on. Draw a line of best fit. Now, when I first started looking at this, I was like, right, okay, I've got to plot my axes at the side first. And I just went straight for 10, 20, 30, 40, 50, because I didn't look properly at the results. And when I looked properly, I realised I've got to get my results up to 85. And that scale is not going to work, so I would have lost marks there. So all I did was think, okay, if I've got to get up to 85, this one, if I double them up, I can get up to 100. That would be a good scale. So all I did is just cross them out and change them and put the correct scale in that would work. That gets me my point. And now all I do is I make sure I plot my crosses extremely carefully. Don't do dots, because your dot will get lost in your line of best fit. You want to show the marker that you have plotted it in exactly the right place. And once you've plotted all your points, you get a ruler, because it's a line of best fit, a straight line, and you put the line where it will go through most of the points. Okay, you can see you've got one on that side, one on this side, but our line will go perfectly down the middle. For this is 1 point for the scale, 2 for plotting, 1 for the line of best fit. Last question. Beth is 1500 millimetres tall and has a body mass of 50.45 kilograms. Calculate her BMI. Well, the body mass is in kilograms, that's okay, but the height is in metres. So I've got to convert that first of all to metres. So 1500 divided by 1000 is 1.5 metres. So 50.45 divided by 1.5 metres equals 22.42. And if the answer is in two significant figures, change it to 22. That's the end of the first video. There's 4 more in this series to help you with your maths skills. Thank you.